Hello and welcome to 9.2, the parabolas. Okay, here we go. Recall the definition of parabola we saw in the last section. The set of points that are the same distance d from a line called the directrix, and a point not on the line called the focus. So here's our line called the directrix. Here's our focus. So every point on this curve will be the same distance. So this distance from here to that point will be the same distance that point to this line. From here to this point, same distance from this point to this line. From here to that point, same distance from that point to that line. That is a parabola. Now parabolas have a really cool property. And you use parabolas, you probably don't even realize it. If you have a satellite dish, use a parabola. If you have a headlight in your car, you're using a parabola. Parabolas really have a neat principle. Take your curve, your parabolic curve, and here's your focus. If this is your light source, light will bounce off. Light will go from the source, hit this curve, and be directed in a path forward. Okay. And that focuses the light. So it's not like a lantern you have sitting on the table if you're on camping, which just sheds light everywhere. This has a focus beam of light. So even your flashlight has a parabolic mirror in there that focuses light in one direction. Likewise, this works in the opposite direction. If you have a satellite dish, and your dish is aimed at the satellite in space, you're getting a signal beam beamed in. So the signal comes in, bounces off the dish, goes to the focus, bounces off the dish, goes to the focus. So you're able to focus all your signal to that one point. That's another benefit of it. Now I've heard of other stories like survival people stories where they take the big gigantic, those 8-foot dishes, and you got to be careful in this. So people burn their hands, second-degree burns. They went to go put a food source here at the focus, and they got third-degree burns just like in the split second that they just reached up there. So you got to be careful with these dishes. They had lined it so it would reflect light into that. Almost you should put it on there before you aim it. Parabolic dishes are really cool things, and we use them all the time. Okay, standard form of the parabola. Assume P is a fixed non-zero real number. The standard form of the equation of the parabola with a vertex at hk, here's your vertex, x and y. X minus h squared equals 4 times p times y minus k if the parabola is vertically oriented, opening up or opening down. Now remember, if it doesn't open up or down, if it opens up sideways, it's not a function. So to be a function, it has to open up or down. If p is positive, it opens up. P is negative, it opens down. The focus is at h comma k plus p. That'll give you your focus. And the equation of the directrix is y equals k minus p. That's just a horizontal line. Now, notice in this case, the y part's squared, the x part's not, versus the previous situation. So if the y part is squared, it's going to open horizontally. Y minus k squared equals 4p times x minus h. Again, p is positive, opens to the right. P is negative, opens to the left. The focus is at h plus p comma k. And the equation of the directrix is x equals h minus p. That'll be a vertical line. Okay, so we're going to do example 1. This is graph the following parabola and determine the focus and the directrix. Well, notice the y part is squared, so it's going to open horizontally. Now our vertex is going to be located, our h is 1 and our k is 4, so 1, 4. I recall it should be x, no, it's y. Y minus k squared equals 4p times x minus h. So 4p is negative 2. P must be negative 2 over 4. P is negative 1/2. That means it'll open to the left. So our focus is going to be located at h plus p comma k. That's going to be 1 plus negative 1/2 comma 4. So 1/2, 4. So this is our vertex. Here's our focus. Our directrix will be located at x equals h plus, I should say minus p. So that's going to be 1 minus negative 1/2, which is 3/2. That's a vertical line. Okay. Now let's get another point or two and then we can draw this curve. If x is 0, what's y? So if x is 0, we have y minus 4 squared is going to be equal to negative 2 times negative 1, that's 2. So for x being 0, y is going to be 5.4 and 2.6. And to get that, again, y minus 4 squared is negative 2 times 0 minus 1. So y minus 4 squared equals negative 2 times negative 1. Y minus 4 squared equals 2. Y minus 4 equals plus or minus 2, square root of 2. So y equals 4 plus or minus the square root of 2. And that's where we get our 5.4 and our 2.6. And then let's do another value for x. What if x was negative 1? We're going to have 6 and 2 for y. It's going to be negative 1 minus 1 is negative 2. Negative 2 times negative 2 is 4. That square root is plus or minus 2, so you're going to have y equals 4 plus or minus 2. Let's plot this out and draw the curve. 0 is at 5.4 and 2.6. 2.6. And then for negative 1, we're at 6 and 2. This is our curve. That's our parabola. Open to the left. Let's try another one. Now the next one's not in standard form, so we have to put it in standard form. That's a big task we have to do first. But you can probably see by the fact that the x is the squared part, this is going to open up vertically, either up or down. Okay. So we have x squared plus 6x plus blank equals negative 8y minus 17 plus the same blank. What goes in that blank? Well, half of 6 is 3. 3 squared is 9. So we have x plus 3 squared equals negative 8y minus 8. So x plus 3 squared equals negative 8 times y plus 1. And there we go. So our center, or I should say a vertex, is going to be located at negative 3, negative 1. Negative 3, because it should be x minus negative 3, y minus negative 1. And then 4p equals negative 8. So p must be negative 2. That means it's going to open down. So negative 3, negative 1. Our focus will be at negative 3, comma, negative 1 plus the negative 2, which is our p. That's going to be at negative 3, negative 3. And our directrix is going to be at y equals negative 3 minus negative 2, or y equals, sorry, it's negative 1 minus negative 2. Y equals 1. Okay. Let's get some points and we can graph this. Let's see here. What points we should go with. A negative 3, we already know what that's going to be. What about if we did x was negative 7 for x. So negative 7 plus 3 is negative 4. Square that, we get 16. Bring that over, we're going to have 24 divided by negative 8, we're going to have negative 3. How about if we go with 1? 1 plus 3 is 4, 4 squared is 16, bring the 8 over, get 24, we get the same thing, negative 3. Okay, so let's plot this one out. When x is 1, y is at negative 3. When x is at 7, y is at negative 3. And there's our parabola. Now we can go the other way. We're going to take information and come up with the standard form of the parabola. So I included a grid on example 2 for this purpose. You can kind of see things when we chart them out. In this case, we have the directrix and the focus. Our directrix is the x-axis. The focus is negative 2, 1. So somewhere between these two, right between them, is going to be our center. Or vertex, I should say. And the vertex would be what? So it's negative 2, 1. The vertex would be at negative 2, comma, 1 half. So negative 2 comma 1/2 is the vertex. And what's our P going to be? Well, P is that distance between the vertex and the focus, or the vertex and the directrix. So P would be 1/2. And this one's going to open vertically, so it's going to be x minus negative 2 squared equals 4 times P is 1/2 times y minus 1/2. So x plus 2 squared equals 2 times y minus 1/2. And that's it. Okay, that was fun. Let's do another one of those. Some more clues. Let's play detective here. Symmetric with respect to the line y equals 1. Y equals 1 is a horizontal line. Directrix is the line x equals 2. So x equals 2 is a vertical line. So that's our directrix. Y equals 1 is a horizontal line. It's symmetrical with respect to this. That means that our focus and our vertex must line on that. So line of symmetry. So directrix is line 2. Okay, now but P is negative 3. So P being negative 3 means it's going to open to the left. Our vertex is going to be then 3 steps from the directrix on this line. 1, 2, 3. Vertex. And that's located at negative 1, 1. That's going to be y minus 1 squared equals 4 times negative 3 times x minus negative 1. Or y minus 1 squared equals 12 times x plus 1. There we go. Let's go on the last page. Okay. Graph the following. Y squared equals negative 2 times x plus 3. So it's a little, to me when I first see that, I'm like, oh, y squared, but so I'm thinking it's going to open up and down, but no, the y is squared, even though it doesn't have a plus or minus in there. That just means it's going to be 0 for the y part. The vertex is going to be then at negative 3 comma 0. Because our 4p is negative 2, p is negative 1/2. So p is negative 1/2. It's going to open up, because it's negative, going to open to the right. There's our focus. And our directrix is right behind it then. So our focus doesn't ask us to find this. I'm going to state it anyway. It's going to be negative 3.5 comma 0. And our directrix is going to be located at what? It's going to be located at negative 2.5. X equals negative 2.5. Okay. So I have to graph this, and when we have those things, you just can plot some points, and we'll be on our way. X and y. So let's say that y is 2. 2 squared is 4. Divide that by negative 2, you're going to get negative 2. And then subtract 3, you're going to get negative 5. Let's try negative 2. Negative 2 squared is 4. Divide by negative 2, you get negative 2. Subtract 3, you get negative 5. How about if we have y being, let's go with x being negative 4. So y squared would be negative 2 times negative 4 plus 3. Y squared would be negative 2 times negative 1. Y squared is 2, so y would be plus or minus the square root of 2, which is plus or minus 1.4, approximately. Okay, so we have a couple of things here. So negative 5 is at 2 and negative 2. And the negative 4 is at 1.4 and negative 1.4. That's that. Got one more example to do here. Okay, I'm going to scroll on. Okay, example 4. One design for a solar furnace is based on the paraboloid formed by rotating the parabola x, I should say x squared, not x2. X squared equals 8y around its axis of symmetry. The object to be heated in the furnace is then placed at the focus of the paraboloid. Again, watch your hand on this as I describe. If you ever do make something like this, do not have it aimed at the sun when you put whatever you want at the hot point, at the focus. Okay, let's place at the focus, place the paraboloid, assume that x and y are units of feet. How far from the vertex of the paraboloid is the hottest part of the furnace? There's a really awesome solar farm. If you ever get a chance to go down there, Kramer Junction. It's Kramer Junction's 395 and 58 in California. And what they have is they have this setup. They have these long parabolas like that. These long dishes that are parabolic in shape. And they put this tube right here at the focus. And they have oil in it. It heats the oil up. The oil goes through the whole system, gets super hot, heats up water, turns turbines, and then makes electricity. It's kind of cool. We're talking about a parabola here. We'll assume the vertex is at 0, 0. And here's our focus. Question is, where do we put that? Well, we have x squared equals 8y, so 4p must be 8y. No, it must be 8, so p must be 2. So it means it's going to go 2 feet above the vertex. And this in terms of feet, I believe. Yes, in terms of feet. So the focus is 2 feet above the vertex. Our focus right up there. So all that heat going to come in here and reflect up to that point. And the one in California, the way it works is it's aimed at the sun. So the sun rises in the morning in the east, and it rotates during the day and follows the sun all the way through to the sunset. It's really cool. Okay, the last part of this, just some notes here. The path described by a thrown object, the absence of friction and other forces, is the parabola. The height h of t of an object with initial velocity, v sub 0 should have, and initial height h sub 0, is h of t equals minus 1/2 gt squared plus v naught t plus h naught, where g is a constant is the acceleration due to gravity. So if we're talking about, for g is going to be 9.8, usually negative 9.8 meters per second squared, for the metric system, and g will be negative 32 feet per second squared for the English system. Okay. And that'll do it for this section. So that's some of your questions, and thank you very much.